Hello everyone, this is Heqiu. I'm a second-year PhD student in Nanyang University of Technology. I'm glad to present a paper here. The topic is about applying psychological theory to child-robot interaction design in musical instruments learning. Here are the information included in this talk. In case you don't know anything about music learning, firstly I want to give you some information about it. Learning a musical instrument has been shown to provide benefits in the long-term enhancement of visual-spatial, mathematical performance, verbal, and social communication skills of children. But how do children normally learn a musical instrument? Let's meet Henry. He's an elementary school student and he has been learning piano for almost 2 years. Like most of the kids, he takes his piano lesson once a week for 20 minutes, and he practiced the things he learned from the teacher 15 minutes a day, 6 days per week, sometimes less. In total, he practices less than 2 hours per week. Malcolm Gladwell states that 10,000 hours is the magic number of greatness in his book Outliers. It looks like Henry still has a long way to go. This was also found in previous studies that formal practicing is crucial for musical instruments learning, and practice is a self-directed activity. As a self-directed activity, focusing on a repetitive task for a long time is a challenge for a child. To get through long-time practice, Henry always has his parents' support, which is very important for music learning. His parents normally schedule and urge him to practice more, which brought some tension to their relationship with Henry. Henry started to have negative feelings about learning the piano. This is also a challenge we have now. Former researchers also found that even though parents are usually not schooled to help the child in learning a musical instrument, they can still help their children by just listening to them, which can be explained by the social facilitation theory. According to this theory, people tend to show better performance in the presence of others on simple or well-rehearsed tasks, but perform worse on complex or new tasks. Furthermore, the evaluation apprehension theory argues that not merely the presence of others, but the evaluative pressure is the main trigger for social facilitation. For example, the evaluative pressure from Henry's parents and Henry's music teacher are different. His parents can raise the motivation and improve his performance, but his teacher is a source of considerable stress, which can cause anxiety. Therefore, the role of the audience can make a large difference in the performer's motivation and performance. Social facilitation can also happen when human experiences to be observed by a social robot. And the use of social robots has been explored in various educational contexts, like math and science, and has been deployed in different roles, such as a tutor, a peer, or as an assistive tool. Built on earlier explorations of the role of the robots during learning, we wish to develop new roles of the robot based on social facilitation theory. For better designs, we did interviews with 2 music teachers and 2 adults who learned musical instruments while they were children, to understand the basic information of musical instruments learning and their needs. Based on the literatures, 2 robot roles with distinctive features of speech, facial expression, head inclination, and outfit were designed, which are evaluative role and non-evaluative role here. The behaviors were designed to introduce the task to the children and provide feedback and encouragement during the practice. After 3 iterations, 36 behaviors which support 9 possible tasks were designed for each role of the robot. For example, the evaluative role would slightly nod its head while the child was practicing, like the robot was following the music. To test the roles we designed, 23 children from a Dutch music school between 5 to 12 years old participated in this study. The instruments of participants were various, including piano, flute, violin, guitar, and others. 3 children's results are not included in the analysis since they were under 8 years old. Children were divided into 2 groups randomly. One of them experienced evaluative robot and the other one experienced non-evaluative robot. The evaluation took place at a Euro music practice room in a Dutch music school. As shown in the picture, there were two areas in this room, a practice area and a Wizard of Oz area. The Wizard of Oz area was for hiding researcher B, who did the monitoring and remote controlling of the robot. After the children practiced with the robot, they were asked to fill in a questionnaire about their feelings. In order to measure children's perception of the robot roles, we assumed that children would feel more nervous with the evaluative robot role than the non-evaluative one. A questionnaire was designed based on the brief version of Fear of Negative Evaluation Scale and the state anxiety items from the State Rate Anxiety Inventory. 2 questions were deleted from the questionnaire during data analysis because the robot didn't make any negative comments and 2 roles had different head movement patterns. By averaging the answers from the remaining 7 questions, the bold ones showed here, we were able to construct a reliable measurement for children's nervousness towards the robot roles. To test the hypothesis that children perceive the evaluative role and non-evaluative role as intended, an independent sample t-test for the 2 groups were conducted. The results showed that children were significantly more nervous with the evaluative robot than the non-evaluative one. According to how long they have learned the instrument, we divided the children into 3 levels, which are new learners, developing players, and experts. We performed an ANOVA with post-hoc text on question 9. The results showed a significant mean effect between 3 different levels. Post-hoc comparison by using the Bonferroni test indicate that the mean score for new players was significantly higher than the developing players. Likewise, the results showed a significant difference between 3 groups by Kuskal-Wallis H-test as well. The observation analysis of the video data we collected showed that most of the children became happier and more enthusiastic about practicing after receiving verbal praise from the robot in the beginning. But the effect went away after practicing a few times. We also noticed that most of the children only got attracted to the robot when the robot was talking to them or making some noise during practice. Otherwise, they only paid attention to the robot every time they finished a melody. This could also be valuable for the designers in child-robot interaction design. The noise produced by the robot motors can be a distraction, especially in the context of music learning. For the limitation and future works, though the sample size may be smaller than the ideal number, the results showed significant differences between 2 conditions. However, it remains important to replicate these findings, perhaps in a larger context. This study only investigated a 15 minutes interaction between the robot and the children, which didn't allow us to find out whether such changes over time will occur. Future research might need to investigate such longer interactions. Finally, future research can also evaluate the 2 roles in other scenarios, thereby expanding the potential usefulness of evaluative social robots. That's all for the presentation. If you have any questions, please feel free to send us an email. Thank you so much for your attention.